What's going on, guys? Welcome to video 2 of the Python for data analysis, or should I say Pandas for data analysis series. Alright, so in this video we will be learning how to create series or data frames, which are the primary data structures of Pandas. Alright, so let's just jump right into it. We will import these first two, Pandas and NumPy, and this actually, we'll just run this, but you don't have to worry about this. This was for debugging purposes. Alright, so now multiple ways of creating a series. So in the last video, we went over a series and DataFrame, and now we're going to learn the multiple ways of creating both of these, or getting your data into these data structures. Alright, so the first thing is array. So this is pretty much a straight copy from the last video. We get a NumPy array, and we just feed it into pd.series. So we do this, this, and this. And s.head just looks at the first 5 rows of the series. So this is just a copy of the last video, so we will go through this pretty quickly. So now the next one, a list. So you don't need an array, you can also use a list. And here we will create a list of a range going from 0 to 20, and the step is 2. So basically it's skipping every 2 steps. So we get the values, and now, just in case you guys want to see the values, there we go. So 0, 2, 4, 6, 8, etc. And now we fit in the values into pd.series. And that's it. Now we have the values 2, 4, 6, 8 and the indices 0, 1, 2, 3, 4. And once again, s.head is just representing the first 5 rows. All right. Now with those two done, let's take a look at something more interesting using a single value. So we're going to take 3, which is the single value, and we're going to create 10 copies of that, range 10. So by putting in a range, in addition to a single value, we'll create a series consisting of multiple rows of that single value. So let me just run this and run s.head, and you'll see that it's just 3, 3, 3 repeated 10 times. So a series is actually 10 rows long. So that's using a single value. All right. The next way, a custom index. Now you could also feed a custom index within the constructor. So p.series, we have a list of values 1, 2, 3, which are going to represent the values, and then we're going to represent the index, ABC, which are going to be the custom labels for the indices itself. So this is pretty self-explanatory. You have the values and you have the indices. So if we run this and look at s.head, you'll see now the indices are not the default values, but the values that we fed in. So we have 2 lists, values and index. And what we're going to do is create a dictionary out of it using index and values and have them zip. I'm going through these pretty quickly because I have a lot of videos, list comprehension or the basics of these things. So if you're kind of shaky, take a look at some of my Python videos, even func tools. I think I go over some of this. Yeah, so that's why I'm going pretty quickly through some of the basics. Now with dict, we have a key and a value. So A1, B2, C3. So you have keys and values. And we feed in this dict, and you'll see, if I just run it, that we get a series with the keys representing the indices and the values representing the values. So those were multiple ways of creating a series or getting our data into a series. Now we're going to look at data frames, which have actually a lot of flexibility, a lot of ways to get your data into a data frame. All right, so first is the dictionary. So we used the dictionary in the previous video, but I'll do it again. So here we have a dictionary with 2 keys, country and city, and the values are 2 lists, Japan, Brazil, India, and Tokyo, Sao Paulo, and I'm sorry if I'm pronouncing it incorrectly, all right, and Mumbai. So we have 2 keys, country and city, and 2 values, which consists of lists. So all we do is feed in this dictionary, and that's it. If I just first run this cell, and that's it. We have a data frame. Very simple. So we have indices 0, 1, 2, and we have 2 columns, a country column and a city column. Very simple. All right. Now a zipped list. So using ZipList. So we take 2 lists, a country and city, because sometimes you'll have your data either in lists or dictionaries. So I felt it was good to show you guys both ways. So if you have a country list and a city list representing 2 different columns, all you need to do is zip them. Oops, let me just run this. On this, okay. So now we have locations, which consists of tuples of the list values. So the country and city have been zipped together, and now we have tuples. And now what we're going to do is assign column names, country and city. Run that. And now we create a data frame by feeding it the locations, which is going to represent the columns, and the columns equals columns, which is basically the column names. So instead of me trying to explain it, let me just run this and run this. And now you'll see that we have a country and a city. So let's just go back up here. We had a list, country list, and a city list. So these are going to represent the column values. We zip them. So we have Tokyo, Japan. So if you look at 0th row, so basically these tuples are representing rows. Tokyo, Japan, Brazil, Sao Paulo. Excuse me for that. Here we go. Let me just run that again. Okay. So each of these tuples are representing the rows, and then we just need to give columns attribute or argument a columns list that's going to represent the names of our columns. So the column names are country and city, and you'll see they match the Japan and Tokyo. They match the len of the tuple, so that's also important. So you have each row consisting of 2 columns, so our columns must also consist of 2 values. And that's it. So this was 2 simple ways of creating data frames. Now let's get into the interesting things. All right, so most of your data is going to be probably in comma-separated values, which can also be used for Excel. So this earlier data frame, what we're going to do is we're actually going to save it to a country.csv. So df.toCSV is basically taking our data frame and saving it to a file. And in this case, country.csv. So I'll run this. All right, so if we look at country.csv, this is a comma separated value format. So you can see each row or each column is separated by a comma. So this is the format. And now Excel can take this format as well. So you can read these files into Excel as well. Unfortunately, on this video, on this computer, I don't have Excel. This is my new PC, and I still haven't installed a bunch of things. So we've saved the data frame to CSV, right? So now what we're going to do is we're going to create a new data frame just by reading that CSV. And we'll run this. Now if we take a look, you'll see that there's a problem. And the way it read it is that it's taking the indices column and thinking it's actually a separate column. So these read CSV or these constructors have actually a lot of options, such as skip rows, index call equals, etc. And I'll go more in depth of all that in future videos. Basically what it's saying is your 0th column will be actually index. So since here our 0th column is actually our index, read CSV actually made a mistake and it made the indices into our 0th column. What we're going to do is index column equals 0 is basically saying our indices should be based off the 0th column. And if we run this, you'll see that fixes the problem. So I'll go a little more in depth of some of the constructor arguments in the future. Now you can also save it to an Excel file. Saving it to comma separated values is more than enough because the comma separated values is a widely used format that can be read by Excel as well as other formats. But sometimes you might have an Excel sheet that you need to read directly, and I'll teach you guys how to do that as well. Now, when you try to run these cells, you might run into some module not found because you have to install a bunch of things. Open PyXL and XLRD. So these are a couple of modules that you'll need to install with pip install before you can get the Excel stuff running. But it's very similar to CSV. What we'll do is we'll convert our data frame into an Excel file, XLSX. All right, so I've done that. So now let's take a look. So now I have XLSX, a data frame, an Excel file, but I can't open it because I don't have any Excel stuff on this PC. But we'll return back here, and I'll show you that I'll actually read. So even if you don't have Excel, you can actually read Excel files with PD. So pd.readExcel, and we'll create a new data frame based off this Excel sheet. So I run this, and .head. And once again, we run into the same problem. So what we can do is index call equals 0. And there we go. And now we've fixed the problem. All right, so those are some of the basic ways of creating data frame. Now I have one more. This list is no means exhaustive, but I wanted to go over some of the more common methods to getting your data into a data frame. All right, so now we're going to use HTML tables from websites. And this can get a little messy, so I wanted to include this as well. But basically, let's go to this website. All right, so this is the website. It's NBA standings 2018-19. So this is just a sport in America for those that are international. And as you can see, there are tables on this site. So you can actually extract the tables using read HTML. So we basically use pd.readHTML URL, which is feeding in the URL. Header equals none is basically just saying that we don't want to use any headers. And skip rows is if you want to skip rows, but in this case, we're leaving it to 0. Now, sometimes this header equals none doesn't really work all the time. So, you have to try it out and see if it's correctly formatting the data. So now, okay, so first let me get the URL, the DFS. Now, DFS is actually not a data frame because each URL can have multiple tables, and read HTML doesn't know which table to extract. So what it does is it creates a list. So if we look at len-dfs, we have actually 8 tables. And if we look at some of them, for example, DFS0, they're not in the best format. So Pandas tries to do its best. Here it's a decent format, but it just has the names of the team. And the first team is actually the column name, which is a mistake. It should be included within the column itself. We have 2. This is completely mangled. Can't use that. All right. So this one is actually pretty good. It has all the values, but it's missing the team names. And this is for the Eastern Conference. Now, this is what usually happens. Actually, it doesn't usually happen, but sometimes things like this will happen. For my use cases, read HTML with stock market stuff actually works pretty well. So in this case, what can we do? We'll have to do a little data pre-processing. So this is very common in data analysis or data science. You have to be very flexible to take sort of unclean data and clean up the format. So a messy format into a clean format. So earlier, let's just look at DFS3. This has all the values, and DFS1 has all the team names. So we want to combine this, but first we got to fix this problem, the Milwaukee Bucks. It should be included within the columns, the column values itself. So what we can do is, first let's look at the DFS1.columns. So we know that the columns names is actually one of the teams, and we need to get that included within the values itself. This was just checking. As you can see, it's a data frame, DFS1. Now the way to get the column header into the column names, there's no easy way. You have to use a little trickery. So here MPV stack is just basically going to stack 2 sort of values on top of each other. So MPV stack will stack DFS1.columns, which is this right here, on top of DFS.1. We'll create a data frame of that, and we'll get the values. So once again, this is probably going to be a little complicated, but basically what we're doing is we're taking the volume, the columns, stacking it on top of DFS.1, which was all the team names. So we're going to be stacking this on top of all of this. So we'll actually get all the values. So the values will actually consist of Milwaukee Bucks as well. Remember, we have to include this within here. So we're stacking this on top of that and creating a new data frame / series. In this case, we're creating data frame. You could probably do series as well. Just use data frame, and then we'll get the values. And let's just run this, and you'll see what this does. So basically now we have an array of all the teams. Now we just have to set our data frame 3, see DFS3, we need to set the index to this instead of, let me just go back here, put that up, okay. DFS3, let's say .head. All right, so basically we're going to be sending the indices to the team names. All right, so set index, and there we go. So now we have pretty much the exact table from here for the Eastern Conference. We'd have to do this for the Western Conference as well, which is, I think, the Western Conference stuff is in table 7. So as you can see, we need to do a little data pre-processing to get the data in the right format. Yeah, so this was a quick introduction to the multiple ways of creating a series or data frames. And I think that's it for this video. In the next video, we will go over some slicing and indices, or indexing, not indices, indexing. All right, I'll see you guys in the next video.